Okay, sorry about this. I ran out of storage on my phone, so just gonna continue where my recording ended. So I started off by reintroducing or reminding you of the definitions of the Fourier transform. So remember, this is a pair of functions that are inverses of each other in some sense. So the Fourier transform of a function f of x is given by this formula here, and this being the Fourier transform. And then the inverse relation is that f of x is 1 over 2 pi. Basically the symmetric thing, except we send x to k here. The phase of the harmonic function changes, and this of course becomes the Fourier transform piece. And what we would like to do is consider the Fourier transform of the delta function. So we'll let that be our f of x. So from this formula, we just go ahead and compute straightforwardly where f of x is now delta function. And now that we know how to manipulate delta functions, we see that this integral collapses, and we're left with just the value of this guy, e to the minus I kx, evaluated at x naught. So we get e to the minus I k x naught. So that's the Fourier transform of f tilde of k. Let's just go ahead and compute the inverse relation to get back f of x to see what happens. If we proceed, we have f of x, just following the formula straightforwardly. Sorry, we're looking now here, so I need this to be plus I kx, and I should be integrating over k, and then the Fourier transform of x goes inside the integrand. Sorry, this is a mess. dk e to the I kx. So substituting that in, we have 1 over 2 pi e to the minus I k x naught. And then simplifying a little bit, this 2 pi becomes a regular 2 pi, and then we have this integral dk of this harmonic function e to the I k x minus x naught. And since we started with this as our assumption, if you will, we know that this is going to be equal to delta of x minus x naught. So in fact, this formula here is another way to rewrite the delta function. And this is actually an extremely useful relation because integrals like this show up all the time in quantum mechanics, and if this whole thing happened to live within an integral over x, say, or a sum over x, then it's very convenient to be able to replace ugly things like this with the simple delta function that would just collapse some sum on x or some integral on x down to its value at x naught. Okay, so the last thing I just want to do is make an analogy with something we saw a little bit earlier, which was the Kronecker delta. So to do that, let me just start by rewriting this guy, this formula here, but basically just exchange the variables x and k. And right now x and k are just symbols, so I'm free to just rename them. And I'm doing this so that the connection to the Kronecker is as clear as possible. But if I just go ahead and replace all the x's with k's and all of the k's with x's, k minus k naught, but maybe I'll just swing the x over here for consistency. So here's a representation of a delta function in momentum space. And last time we were looking